All right, everybody may now give us their wise answers to the 10,000 questions that this guy has just asked without any answers, I think. Pierre and a couple of others who joined a little bit late, you might have noticed that we speeded up the soundtrack a bit. Otherwise, it was going to take an hour. But Pete Quover is hungry, and I'm sure a few others are too. So if you've got any comments or questions, let's get through them quick. Let's see who's present here, participants.
Well, I think this is this whole series was now summarized by what if. And in a certain sense, the question, what is reality, is very analogous to the question, what is time? Reality, I think, as I experience it, and I think as human beings experience it, is what the universe as you see it now, where you are at one instant in time. And that is what you perceive. Whether there is an independent reality, like you also ask, is there an independent time, I think is a moot question. But it's at least interesting food for thought. So I enjoyed it.
Yeah, I agree. I enjoyed it. I don't have a problem keeping it for myself a simple view of reality is just what I experience, and that's that. I'm not bothered to. But it is an interesting question. I mean, I can imagine a bunch of aliens up somewhere in another world, another universe, going to universe manufacturing class, and a bunch of alien students sitting there and being given a task. Go and decide what parameters you need to create a universe and create it for your homework and bring it into class tomorrow. So as a thought process, it's interesting, and it's something that I've often thought about. What are the very basic, very minimum requirements to create a universe? And that is, the most fundamental thing which we are trying to actually decipher and work out. Is there anything that creates quarks, or quarks the final reality? Is there another thousandth of a size to get to until we get to Planck quantities and so on, something else? So yeah. Let's see who's there. Pierre, I thought right in the beginning of, I think you hadn't joined yet. There was you made some comment about a neutron is made of two up quarks and a down quark, and then somewhere it gets an impulse or a jitter or something, a wave or something, and it changes to a proton and it forms something else. I don't know. Was he just? That's not something that actually happens. It was just a theoretical statement.
No, it's a physical reality. You do get proton and neutron decay. There's no doubt about it.
Okay, so neutron. So is that only something which decays to a proton in something with a very heavy core, like a radioactive material, or does it happen with everything?
I think it happens.
Are some of my neutrons becoming protons right now?
Yeah, but the time scales are huge. The age of the universe type thing.
Okay.
But that happens with fundamental particles. Radioactive decay is the fastest sort of example of that. But he also asked the question about consciousness and why is it limited to humans? I don't think consciousness is limited to humans. I think every animal, any insect is conscious of what's happening around it and it reacts to that environment. So consciousness is not limited to humans, but intellect or the ability to creatively think, I think is unique to humans. Kees Reistek asked the questions, what is life many, many years ago? And that still remains valid. Is intellect limited to human beings? We tend to think so, and I tend to think so at the moment. But why?
Yeah, consciousness, I think actually even plants, plants, science has, recent years and decades, science has found that plants communicate with each other. If something happens at one end of a forest, the plants at the other end find out about it. Okay, I mean, that's by means of chemicals and whatever, but still, it is a sort of consciousness.
I think they were talking in the video about things following simple rules, weren't they? I think like when you watch a flock of birds flying around, they seem to wheel around like a cloud, but they're only reacting to their immediate surroundings. But it gives you like an illusion that the whole cloud is behaving as one conscious body. So I don't know.
I don't know.
For like
I
ants
think
in
there is genuinely a bit more to it. There is, well, it's a form of communication, and that almost goes back to sort of Newtonian theory of everything is predetermined. I don't believe
Mhm.
that is the case. I think there is, yeah, I think it's, I don't know. I think it's partly learned response, partly each individual, even an individual ant makes a choice, but he goes with the flow to be part of the herd. But I think it's more complex than just being deterministic and just following rules.
There's a computer program, I don't know if you've ever heard, called Conway's Life. Um, it's basically played on like a grid, and it follows some very simple rules. I'm not going to go into the
Yeah.
list of rules now, but if you play it out, you can almost imagine it's like life. That's the reason why it's called life. But
Mm.
it's nothing more than following a simple set of rules.
Yeah. Yeah, sometimes we want to overcomplicate things, but I think things are not as simple as we believe. Even if you think just of our DNA, I personally believe our DNA is a binary code. And I think people think each gene is just one thing on its own that does one job, or maybe, I don't know, maybe it does more than one job, but two jobs, but that's it. That's it. I think there's a lot more to it than that.
I think yeah, I almost would feel instead of watching this at 1.5 at time, I need to watch it at about 0.75 so that I could. It's really amazing how watching it quicker actually does give a different perspective, but you're obviously missing a lot, or I am, because of but the common feeling that I get out of, or the love of astronomy and geology, even, because of the times and uh, the mystery of it all is what I think is a dimension that doesn't quite get covered. The actual enjoyment and wonder. So long as people are doing the science with that respect of, I'm not meant to understand all this, but it's in me to strive to understand it, to appreciate it, but don't ever think it's going to get that simple. Um, because yeah, I think it's just one great mystery that we there to kind of appreciate and not expect to fully understand. And that to me, almost differentiates what AI can produce. I don't think that it can experience that feeling, as I understand it so far.
I think you've got a good point. I think this particular chapter, what do you call it, session of history of the universe, it's all about a list of all the mysteries that face science, which we don't really have answers for, really. I think, when they say what is reality, it's actually listing all the stuff that we don't really have answers for. And I believe that some of the things that they think we have answers for are also quite possibly not quite the right answers, or maybe even the wrong answer. So yeah, it keeps you focused and it keeps you interested in science, because there's everything to learn still, I believe.
I think if we didn't know everything, then it would be a very boring universe, wouldn't it?
Yeah.
Yeah.
So I'm just Pierre, I'm just on this page here where where he spoke of this. You say it does happen. Where's this thing?
But just by way of illustration, the half-life of a free neutron is about 15 minutes before it decays and eventually becomes a proton. The estimated, or the lowest estimate of the half-life of a proton is 10 to the 34 years, not 10 to the 10 like the universe. So it's almost
Okay.
infinite.
Yeah.
And I actually think you can trace it back to the fact that the neutron is, I think, 0.14 or 0.15, but ballpark 0.1% more massive than the proton.
Okay. It's just
So
got no charge.
there is, let's call it mass energy available to be converted into a lighter particle and then other particles or radiation, and not the reverse.
So the change is just within it, an up quark converting to a down quark, essentially,
Yeah,
and then some stuff being released as a result.
yeah, but there must be energy available for the
Yes.
process to take place.
Yes.
That muon, I think it was Elaine put on that where it was like a 1/44,000th of a second that it appears, and whereas if you could get it to run at the speed of light, it would slow that down to about an eighth of a second, which then becomes something that you can start to, I don't know, photograph, whatever, that you can start to study. Much the same as to find the Higgs boson. They had to develop that huge bit of a kit to do it. Likewise, to find out what the next level of quantum minimalistic things. I don't know what it costs to try and get a muon to the speed of light, where you're almost at the speed of light. You can start to see a bit more about what happens, whether that's the event horizon or wherever that happens. But yeah, there's definitely, it just gets, the quantum is just too large and too small. So I just think that's an amazing mystery, which we appreciate.
Yeah, time varying for an individual because it's going almost the speed of light. Of course, a muon does have some mass, I think, and so it can't travel at the speed of light. But you get the muons coming in from there are particles which hit our upper atmosphere and shoot out muons which travel down to and can be detected on the surface of the Earth, which it shouldn't be able to do because it wouldn't have time to reach the surface of the Earth. But because it's traveling close to the speed of light, as you say, its lifetime gets stretched to where it can be detected on the surface of the Earth. And then, of course, I think there's a muon imaging that somebody's invented, and they've done muon imaging of the pyramids and stuff like that.
Well, that was the fact that you observe muons at sea level or even below Earth is one of the classic proofs of time dilation.
Yes.
According to the muon's clock, it's got its normal half-life. According to a clock stationary on Earth, it shouldn't live so long.
Yeah. So the muon doesn't know that it's lived that long, does it? It's only we that know it's lived that long because we're not traveling at the same speed.
Yeah, it's
I
different
forget how
clocks.
relativity works.
No, it's time dilation, quite literally.
Yeah.
The clock traveling with the observer is always traveling the slowest.
Yeah.
All other clocks are moving relative to it and therefore moving faster.
Actually, something that was touched on in this video, they're talking about black holes. I do wish later on this month that Roger Dean was going to speak about black holes because he's like an authority on it. I wish he was covering some of this stuff.
Well, he better be ready to answer a lot of questions about it because I'm going to have a list of black hole questions for him.
Yeah,
Never
I've
mind
got a
what he's
load as
talking
well.
about. But I was actually thinking I must go and research what I can find out about what he's been doing lately.
That's
maybe
right. We might never
he's
see
going to
the
talk
guy
about
again.
he's going to talk about meerkats. So maybe I will just go and research all the stuff that they've been doing anyway, so that I'll try and preempt and work out some questions before he gets here.
Yeah, at the time when he got the award, I think it was him and it was the Tuckies and the Wits astronomy kind of sections together who were first people to kind of get a picture of or proof of photographic proof of the black hole existing in the Milky Way, and that was where. And I think at a global level, we were right up there. Pierre would know exactly what the award was about, but it was the President's Award or something for our equivalent
No,
of
no,
the
no.
Nobel.
This was a global. This was a global thing. He was part of a global team of hundreds, if not thousands, of scientists working on it.
Yeah.
Yeah, well, that was the event horizon for photographing, taking the first photographs of, well, the first two photographs of black holes. But the South African contribution had mainly to do with the algorithms to actually interpret the data. And that was quite crucial.
Okay.
Yeah.
Right.
And I think he's quite involved in the planetarium in Joburg at Wits there. They put in, they had cameras of way back and they spent a lot of money a couple of years back. And he was on that project of updating all the kit that could give far better. I don't know whether that was more a physical thing, but he was certainly. I know because my son was involved from sort of the digital side in that process, and he was tied up in that. So,
Well, I think it's interesting that the Wits Planetarium has got, or Wits Observatory has got a sister telescope to the McLean. And that was actually used to detect, I think, Proxima Centauri,
yeah,
Rose Innes, and the McLean are both of them 26.5-inch refractors. So they're almost identical, made by the same companies and about the same age.
yeah.
Is it 26 inches?
Don't forget the last half-inch, Derek.
Sorry?
26.5.
Yeah.
Well,
I knew it was big,
I-
but I didn't realize it was that big.
I have to be careful there because it's actually, you were talking about the Innes telescope. It's not 22, it's 46 so across. And when I last serviced, we did some service on it because I was stationed at observatory. It had been going, Innes, for the Innes telescope had been going, and it was in perfectly good nick. And the astronomer who was running it was an American called Wilson. And then we had our astronomer from that, his name was Walter Beek. And the most important thing about it all, and I've always been upset about it, is that the room at the bottom, the library, dated right back to 1600. And that's not using the telescope, that was an observation point. And the books, all the books in that library were all hand written with a quill pen. That you don't touch anything, you stand and just look and think.
Amazing.
But anyway,
No,
anyway,
no,
that's all right. I
I
think
just
it's-
Googled it. The Innes telescope is a 26.5 inch.
that's it.
The Innes refracted telescope at Wits. It is a 26.5 inch.
Yeah, 26.5 inches.
Yeah.
My
I thought-
apology, the McLean is a mere 24 inch. So the inner
Yeah,
is
that's right.
26.5.
Okay. Wow. All right. All right. Has anybody got anything they would like to say? Because I think people are hungry.
Thank
Oh,
you.
that
That was
Very
enjoyable.
interesting. Yeah, thank you.
All right.
Yeah,
We look forward to the next
very
one.
interesting.
Thanks for your attendance.
Yeah,
Enjoy
Yeah.
your
Thank
evening.
you. Thank
Cheers.
you. Bye-bye.
definitely.
Thanks a
See
lot,
you next
everybody.
time.
Cheerio.
Yeah, good night. Good night.
Bye.
All right.